A parabola is the graph of a quadratic function, which can be written in the form of f of x equals ax squared plus bx plus c, where a is not equal to 0. Now the a, b, and c, those would be numbers. For example, it might be f of x equals 3x squared plus 4x plus 5, or g of x equals that, or y equals that. Remember, f of x, g of x, h of x, y, they all mean the same thing. They are the y values, or the output. An example of a quadratic function is f of x equals x squared minus 4x plus 4. This is the graph of that quadratic function. So the graph of a quadratic function or quadratic equation is called a parabola. It's a U-shaped graph. The vertex form of a quadratic function is f of x equals a times x minus h squared plus k. Again, where a is not equal to 0. Because if a was equal to 0, you wouldn't have a quadratic function. The axis of symmetry, it's the vertical line that goes directly through the vertex of the parabola. It divides the parabola into two mirror images. So it's an imaginary line that goes directly through the vertex. Now when we graph a parabola, it's not going to be part of the graph, but you have to know that it is there. It's the vertical line that divides that parabola into two mirror images. The equation of the axis of symmetry is x equals h. Now h is the x-coordinate of the vertex. So the equation of that axis of symmetry would be x equals, and then it's the x-coordinate of the vertex. The vertex is the turning point on the parabola. The vertex of the parabola is at hk, where h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. The vertex is the intersection of the parabola and that axis of symmetry. So the vertex, again, that's the turning point on the parabola, has coordinates of hk. H is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. The parent quadratic function, all other quadratic functions can originate from the parent function. The parent quadratic function is f of x equals x squared. So some points to note on that parent function would be at 0, 0, the origin. That is on the graph of the parent function f of x equals x squared, where x is 0 and y is 0. Another point is 1, 1, where x is 1, y is 1. That is another point on the parent function. And also negative 1, 1. Those 3 points, negative 1, 1, 0, 0, and 1, 1, are all points on the parent function of the quadratic functions. So it's on those 3 points are on the parent quadratic function. The axis of symmetry on that parent quadratic function is x equals 0. It's the vertical line that goes directly through the vertex. So x equals 0, it's not really in the graph, but you have to know it's there. That's the vertical line that separates that parabola into two mirror images. So the axis of symmetry, that is x equals 0 on a parent quadratic function. Goes through the point 0, 0, which is the origin. F of x equals x squared written in vertex form. Now vertex form for a quadratic function is f of x equals a times the quantity x minus h squared plus k. If you want to take that parent function, f of x equals x squared, and put it in vertex form, the x-coordinate of the vertex is 0, the y-coordinate of the vertex is 0. So that would be f of x equals 1 times x minus 0 squared plus 0. That is the parent quadratic function written in vertex form. Going to graph the quadratic function f of x equals 1/2 x squared. Now graphing by hand is not something you're really going to do a lot of. Usually when it comes to graphing quadratic functions, you're going to resort to a graphing calculator. It's by far the best way to graph a quadratic function, the easiest way. But this is how you would do it by hand or on paper. F of x equals 1/2 x squared. The first step is to get that in vertex form so that you can see and identify what the vertex is. If you get that in vertex form, it's going to be 1/2 times x minus 0 squared plus 0. So the x-coordinate of the vertex is 0, and the y-coordinate of the vertex is 0. Then you're going to plot the vertex, put a point at 0, 0. And then also draw the axis of symmetry. Remember, the axis of symmetry is the vertical line that goes directly through the vertex. Now that's really not part of the graph. You're going to lightly sketch that in just so that you know where it is. Step 2 would be find and plot 2 points on one side of the axis of symmetry. So for example, we're going to take x equals negative 2. So negative 2 would be on the left side of that axis of symmetry. So you're just going to have to substitute negative 2 in for x. So if you put negative 2 in for x, then you'll have the y-coordinate. So if you put negative 2 in for x, it'd be 1/2 times negative 2 squared. So we're substituting negative 2 in for x into that quadratic function. So 1/2 times negative 2 squared, that is going to be 1/2 times 4, and half of 4 is 2. So 1 point on this parabola would be at negative 2, 2. We put negative 2 in for x, we got a y value of 2. So negative 2, 2 is a point on the left side of that parabola. Pick another point to the left of the axis of symmetry, or another point to the left of the vertex. I'm just going to use the x-coordinate. We're going to substitute an x-coordinate that's on the left side of that axis of symmetry in to that equation. So let's say x equals negative 4. If you put negative 4 in for x, it'd be 1/2 times negative 4 squared. That is going to be 1/2 times 16. And 1/2 times 16 is 8. So when you substitute negative 4 in for x, you get a y value of 8. So that means negative 4, 8 would be another point on that parabola. Now, the more points you get down, the more accurate your parabola will be as far as graphing this on paper. Again, graphing calculator is by far the best, most efficient, easiest way to graph a quadratic function. Doing it on paper is not real accurate, not a lot of fun, but this is how you would do it. So we have the points negative 2, 2 and negative 4, 8 on the left side of that axis of symmetry. Remember, this axis of symmetry splits this into two mirror sections. So this point right here, negative 2, 2, if that's on the left side of the axis of symmetry, the point that matches that on the right side would be at positive 2, 2. It's just 2 to the left of the axis of symmetry, so go 2 to the right, and the y coordinate will be the same. Likewise up here, this point that we had at negative 4, 8, negative 4 is 4 to the left of the axis of symmetry, so positive, go 4 to the right of the axis of symmetry. That point would have coordinates of positive 4, 8. So there you have 4 points, 5 including the vertex, for that parabola. Now again, this is not real accurate. The more points you put down, the more accurate your parabola will be. But your next step is to draw a curve through those 5 points, and that would be the graph of that parabola. It's a rough graph of that parabola, but that's similar to what it would look like on a graphing calculator. We're going to look at the graphs of two quadratic equations, y equals 3x squared and y equals negative 3x squared, and we're going to identify the difference between those two. So y equals 3x squared, that would be the graph of that equation. It's a parabola. Vertex is at 0, 0. And y equals negative 3x squared, again, that's a parabola. This parabola, though, opens downward. So this parabola over here on the left opens upward. This parabola on the right opens downward. So what's the difference? Y equals 3x squared, y equals negative 3x squared. You can see that this parabola opens upward, this parabola opens downward, but basically they are the same. It's a reflection over the x-axis. Remember, when you take the negative of the value of y, that reflects the graph over the x-axis. And that's what's happening here. We're taking the negative of the value of y. The value of y is the whole right side. If you take the negative of that, get y equals negative 3x squared. That creates a reflection over the x-axis, and that creates this parabola. So what can you identify from this if you are just looking at the equations? So if you're just looking at the equations, you see the number in front of the x squared, the coefficient of the x squared is positive. That parabola opens upward. The coefficient of the x squared here is negative. That parabola opens downward. So if a, the number in front of the x squared, if that's greater than 0, if that's positive, the parabola will open upward. And also with that, the y coordinate of the vertex is going to be what's called the minimum value of that function. The value of a function is the y value. At any point on that parabola, the value of that function is the y value. So if the number in front of the x squared is positive, the parabola will open upward. If the number in front of the x squared is negative, the parabola will open downward. So here, this parabola opens downward because a, the number in front of the x squared is negative. It's less than 0. And also the y coordinate of the vertex here is a maximum value, or is the maximum value of that function. So when the parabola opens upward, the y coordinate of the vertex is the minimum value. When the parabola opens downward, the y coordinate of the vertex is the maximum value. Once again, very important, if the coefficient of the x squared is positive, the parabola opens upward, and the y coordinate of the vertex is the minimum value. If the coefficient of x squared is negative, the parabola opens downward, and the y coordinate of the vertex is the maximum value. So just a reminder, the graphs of y equals ax squared and y equals negative ax squared are reflections over or across the x-axis. Y equals x squared, the number in front of the x squared is positive, that parabola opens upward. Y equals negative x squared, the number in front of the x squared, or the coefficient of the x squared there is negative, that parabola opens downward. So you can tell which way a graph opens, up or down, based on the coefficient of x squared. If it's positive, it opens upward. If it's negative, it opens downward as far as parabolas and quadratic functions are concerned. Increasing the absolute value of a, the number in front of the x squared. In other words, if you multiply that by a number greater than, if you multiply the y value by a number greater than 1, that's going to stretch the graph vertically and narrow it horizontally. So if you take that y equals x squared and you go to y equals 2x squared, where you're multiplying the y value, the whole right side, by a number greater than 1, in this case 2, you can see that graph is stretched away from the x-axis. So what's happening there is you're taking every y value on this graph and you're multiplying it by 2. That's naturally going to stretch it away from the x-axis and narrow it up. If you decrease the absolute value of a, that's the number in front of the x squared. If you decrease that, that compresses the graph vertically and widens it horizontally. So in other words, if you take that y equals x squared, you multiply the y value by a number between 0 and 1, that will decrease the absolute value of a. If you multiply that by a number between 0 and 1, that's going to compress the graph down toward the x-axis. So if we go from y equals x squared to y equals 1/2 x squared, where we're multiplying the y value by 1/2, multiplying every y value on this graph by 1/2, that's going to compress the graph down toward the x-axis, or widen it out. So again, y equals x squared, the number in front of the x squared is positive, that parabola opens upward. Y equals negative x squared, the coefficient of x squared is negative, that parabola opens downward. When you go from y equals x squared to y equals 2x squared, where you're multiplying the y value, the whole right side, by a number greater than 1, it's going to stretch the graph away from the x-axis, or narrow that parabola up. If you go from y equals x squared to y equals 1/2 x squared, where you're multiplying the y value, the whole right side, by a number between 0 and 1, in this case 1/2, it's going to compress the graph down toward the y-axis, or in other words, widen that parabola out. Just a reminder, vertex form of a quadratic equation, a quadratic function, is y equals a times x minus h squared plus k, where h and k, those are the coordinates of the vertex, and the axis of symmetry, it's the vertical line that goes directly through the vertex, that would be x equals h, or x equals the x coordinate of the vertex. We're going to take a look at translations of the parent function f of x equals x squared. So if we go from f of x equals x squared, the red graph, to g of x equals x squared minus 5, the blue graph, you can see that the red graph to the blue graph, it's shifted down 5 units. So when you subtract 5 from the value of y is the whole right side. When you subtract 5 from that, imagine every point on that red graph, if you subtract 5 from the value of y, it's going to shift the graph down 5 units. And you can see that takes place from red to blue. The graph is shifted down 5 units. So on that red graph, f of x equals x squared, the vertex is located at 0, 0. The axis of symmetry, the vertical line that goes directly through the vertex, that is x equals 0. It's x equals, and then it's the x coordinate of the vertex. For the blue graph, g of x equals x squared minus 5, its vertex, since we shifted down 5 units, we went from 0, 0 now to 0, negative 5. Its vertex is 0, negative 5. The axis of symmetry, though, didn't change. We didn't go left or right any. It's still right on x equals 0. So you can see when you go from f of x equals x squared to g of x equals x squared minus 5, the graph is shifted down 5 units. The axis of symmetry doesn't change, but the vertex does. I'm going to start with f of x equals x squared. That's the red graph, and go to h of x equals x minus 4 squared. Now, if you remember translations, remember when you subtract 4 from the value of x, it's going to shift the graph to the right 4 units, and you can see that there. If you subtract 4 from the value of x, from red to blue, the graph is shifted to the right 4 units. So the translation, you would label that or say that is shifted to the right 4 units. So for f of x equals x squared, its vertex is located at 0, 0. The axis of symmetry is x equals 0. But the blue graph, its vertex, since we went to the right 4 units, its vertex is at 4, 0. And the axis of symmetry is at now x equals 4. Axis of symmetry is the vertical line that goes directly through the vertex. Remember, vertex form is f of x equals a times x minus h squared plus k. So if this is showing up as x minus 4 squared, the x-coordinate of the vertex is positive 4. Don't get confused there. If it's just like vertex form x minus h, and this is x minus 4, the x-coordinate of the vertex is 4. So don't get confused when you're looking at an equation and you're picking out the vertex. If it's in this form, x minus h squared, the x-coordinate of the vertex is that number, in this case 4. Now if that was x plus 4 squared, the x-coordinate of the vertex would be negative 4. Because remember, when you add 4 to the value of x, it shifts the graph to the left 4 units. So if that was showing up as x plus 4, the x-coordinate of the vertex would be negative 4. How's the graph of g of x equals x squared plus 3 a translation of the parent function f of x equals x squared? So what took place when you went from f of x equals x squared to g of x equals x squared plus 3? Well, you're adding 3 onto the value of y. The value of y is this whole right side, or it is x squared. So if you add 3 onto x squared, or 3 onto the value of y, imagine every y coordinate, if you're adding 3 onto it, it's going to shift the graph up 3 units. So f of x is translated up 3 units. You can see that from blue to red. The blue graph is f of x equals x squared. The red graph is g of x equals x squared plus 3. From blue to red, you can see the graph is shifted up 3 units. How's the graph of h of x equals x plus 1 squared a translation of the parent function f of x equals x squared? So we're going from f of x equals x squared to h of x equals x plus 1 squared. We're adding 1 onto the value of x. Remember, when you add 1 onto the value of x, it's going to shift the graph to the left 1 unit. When you subtract 1 from the value of x, it shifts the graph to the right 1 unit. So from f of x equals x squared, that's the blue graph, to h of x equals x plus 1 squared, that's the red graph, you can see from blue to red, it's shifted to the left 1 unit. So f of x is translated left 1 unit to end up at h of x equals x plus 1 squared. What is the vertex of the function y equals 3 times the quantity x minus 7 squared plus 4? Remember, your vertex form is a times the quantity x minus h squared plus k. The vertex is located at hk. The axis of symmetry is x equals h. So that x minus 7 is what we're going to look at first. That's in the form of x minus h. So that 7, just like this h, is the x-coordinate of the vertex. So we're looking for an x-coordinate of the vertex to be 7. It's either going to be c or d. Now for the y-coordinate of the vertex. Remember, the y-coordinate of the vertex is this k. So if that's showing up as plus 4, the y-coordinate of the vertex is 4. So the x-coordinate of the vertex is 7. The y-coordinate of the vertex is 4. Correct answer there is letter D, 7, 4. Which is the graph of the function f of x equals negative 2 times the quantity x plus 3 squared plus 5. Well, there are things you can pick out just by looking at the equation. You can tell which way the parabola opens, up or down. And you can also pick out the vertex. Remember, vertex form for a quadratic equation is f of x equals a times the quantity x minus h squared plus k. H and k would be the coordinates of the vertex. So in that equation, that function, f of x equals negative 2 times the quantity x plus 3 squared plus 5, the x-coordinate of the vertex is what we'll look at first. And that's showing up as x plus 3 inside the parentheses. Vertex form is x minus h. So if that's showing up as x plus 3, to get that plus 3, you would have to do x minus a negative 3 in vertex form. So x minus h would actually be x minus a negative 3. So the x-coordinate of the vertex there is negative 3. Now if that was showing up as x minus 3, the x-coordinate of the vertex would just be 3. So the vertex is at hk. This is x plus 3. That means the x-coordinate of the vertex is negative 3. The y-coordinate of the vertex is just going to be what's showing there. It's positive 5. So the vertex is located at negative 3, 5. So looking at the graphs, you can look at which ones have a vertex of negative 3, 5. Letter G, letter F. Each of those have a vertex located at negative 3, 5. Then you can also tell which way the parabola opens based on this negative 2 out front. Remember the number in front of the x squared, in this case, the x plus 3 squared, if that's negative, the parabola opens downward. If that's positive, the parabola opens upward. So if that was a positive 2, we'd probably be going with letter G. But it's negative 2, meaning the parabola opens downward. I'm going to go with letter F. So once again, the vertex is located at negative 3, 5. If that's x plus 3, the x-coordinate of the vertex is negative 3. The y-coordinate of the vertex is just going to be what's showing there, positive 5. So the vertex is negative 3, 5. This negative sign out in front, that means the parabola opens downward. If that was positive, the parabola would open upward. So with a vertex of negative 3, 5, negative 2 out front, that means the parabola opens downward. Letter F is the correct answer.